recording is for Marine Biology Module 15, which deals with ocean resources. So in this module, we will be primarily talking about what resources the ocean provides for people. And then in the next module, we will be talking about the impact that people have on those resources. So in terms of ocean resources, we will be talking about how the ocean is used for food. That's one that we obviously think of right away. But then, in addition to that, the ocean can also provide us with chemicals, and the ocean provides us with recreation. So these are the three areas that we will be discussing in terms of how man benefits from the ocean. So with regard to food, we're going to look at a figure here that will show the relative amounts of finfish and shellfish that are harvested from the ocean. So this figure, so this is these are worldwide data, and the blue bars represent marine fish. The purple ones represent marine mollusk, and then the yellow ones represent marine crustaceans. So what you should see from that is that most of what is being harvested are fish, and then the mollusk, like clams and oysters, and then crustaceans, which would constitute things like shrimp and crabs. Those are harvested in much smaller quantities than the marine fish, and we'll look a little more specifically at that in a little bit later. Okay, so in terms of fishing, we know that fishing is a big business. And it also serves as a source of protein around the world. And so with commercialized fishing, which means that there are now larger ships, satellites can be used to locate large schools of fish. Fishermen are able to stay out longer periods of time, and as a result of these things, we are seeing that the fish populations are declining. So we'll be looking at some of the factors related to that decline in the fish populations. Where are the best locations for fishing? Well, if we think about the areas of the ocean that we have studied so far, well, the best locations for fishing are going to be in the photic zone. Because remember, in the photic zone, there's going to be a lot of producers, and therefore those producers will provide food for the the fish that are going to be harvested. And then also, these areas are also near the coast. So if they're near the coast, that means they're closer to people. So here we're basically talking about areas around areas on the continental shelf. So in terms of the most productive areas of fishing areas, we generally think of the Northwest Pacific area, the Northwest area around the Pacific Ocean, and then the Northeast Atlantic Ocean area. And of course, these areas are also, if you're near an industrial area, then you can take advantage of the harvest from these areas. So most of them are from the continental shelf, and in that photic area of the ocean. So what is being caught? Well, about 25 to 35%. So what is being caught? About 25 to 30%. So about a third, a fourth to a third, are what we call clupioid fish. And what the clupioid fish are they are small fish, and these are small fish that eat plankton. And also these fish tend to travel in large schools, so you can catch a lot of them at one time. And so these include things like anchovies, sardines, and herring. And in terms of how these are caught, what is often used to catch the clupioid fish is something that is called a purse seine. Um, and it's basically a long, flat net um, with weights on the bottom. And once the fish are inside, then the weight end is drawn up to trap them. So it's called a purse because it's basically like a drawstring purse. So these smaller fish that are caught in this Persian, what do we use those for? Well, many of these are not directly used for food, but they are ground into fish meal, and then that gets added to other foods. So anchovies and herring, though they're not mostly consumed as fish, but they are ground into fish meal that then gets added to other foods. Some are pickled in parts of the world. They are pickled or canned. And then eaten as a food source as they are. In some of them, we extract the oil from these fish, and then that oil is used in paint. So in other words, most of them are not directly used for food, but they are used in other ways. Okay, so that's the 25 to 30% of what is harvested are the cupioid fish. And then the next most common are the fish that are called the gadoid fish. And these are larger fish. They tend to be on the bottom or near the bottom. And these are fish, they're not going to eat plankton, so they're going to eat things that are above plankton in terms of the energy level. So they eat things above plankton. So they're going to eat things that eat plankton. And so these are things like cod, pollock, and haddock. So these are things that tend to live more in cold water. And in terms of how they are caught, we can go back to our figure. So in these types of fish are more likely to be caught in a trowel. So it's a net that's shaped like a bag that is dragged along the floor of the continental shelf. And the fish are then caught in this way. Now there are other bottom dwellers like redfish, bass, rockfish, flounder, halibut, salmon, and mackerel. Those also could be caught with a trawl. So let me go ahead and write up here that most of these are caught using a troll. Okay, then, so that's the gaboid fish. When you get to the open ocean, so now we're off the continental shelf, then we start to see things like, more like tuna. So tuna is it's a carnivore that will eat the clupioid fish. So in this case, the way that the tuna would typically be caught is using a long line. And this is especially true for catching tuna that don't travel in large schools. There are some tuna that travel in large schools, and then you would use some kind of net for those. But if we look at the long line, so it consists of a main line that is baited with hooks, and that's moved back and forth. And so then when fish are caught, then you just remove the hooked fish and you rebait the hooks. So things like tuna are caught primarily with the long line. And then lastly, we have gill nets. So these are large. A gill net is a large rectangular shaped net that can either be anchored or it can just be left to drift, but fish get entangled in the net. The problem with using a gill net is marine mammals and even fish that you aren't intending to catch also get caught in a gill net, but they are one way that is used to catch various types of fish. If we go back to our figure where we looked at I can't seem to find that figure now, but when we were talking about what is harvested, the least amount of what is harvested are the shellfish. So if you want to look in your book, we're looking at figure 15.1. So the other things that are harvested are the shellfish, which includes the mollusk and the crustaceans. So the mollusk would be things like squid, octopus, clams, oysters, mussels, and scallops. The crustaceans are things like shrimp, lobster, and crab. And then we also harvest seaweed, and we've talked previously about how seaweed is used in foods like puddings, salad dressings, ice cream, toothpaste, as a thickening agent. And of course, some seaweed is also used in sushi, but a lot of it's used as a thickening agent in these other types of food. One area that is a little presents a little more controversy is when we talk about harvesting things like whales, sea turtles, and seals. And the issues here relate to the fact that in some areas of the world, these are harvested as a food source, and in many of these same parts of the world, it is part of their tradition, and may even have some religious significance to the people. But the question becomes, should they be allowed to continue to hunt these animals, because they are certainly threatened and in many cases endangered. So one of the main issues that we have to talk about in terms of how man is benefiting from the ocean is managing the populations. And so in that regard, we have what are renewable resources. And renewable resources are those that can, where you can naturally replace what is harvested. But then there are non-renewable resources. And those are where you're not able to replace what is being harvested. But the thing to remember about renewable resources is that if you remove them at a rate that they can be removed from the ocean at a rate that exceeds their ability to be replaced by reproduction. So if too many are removed, then there's going to be fewer that are left to reproduce, and that's going to affect the population size. So the problem here is overharvesting, because if we overharvest, then what has happened is that there are fewer left to reproduce, and then that is going to affect the that's going to affect the population. It's going to result in a smaller population. So from all that, we come up with the idea of a sustainable yield. And sustainable yield, just that's how many can be caught without reducing the size of the population, so that you won't lose the species. Or this, we also had to be concerned about overpopulation. So how many can be caught without reducing the size of the population or letting the population grow so large that the population gets too big and the area cannot sustain it. So this idea of sustainable yield is something that is really important so that we don't threaten the long-term population size. So with overfishing, for example, with overfishing, you're going to get a greater yield of food, but the result of that would be that the population would decrease. And of course, this also many times is driven by profit. So, and also by the amount of food that is needed to sustain people. But if people are allowed to harvest fish at any rate, then we're going to lose these fish populations, which ultimately then would be detrimental to not only because it'll be detrimental to the fish population, that's going to be detrimental to our ability to provide food for people. I mentioned whales earlier, and whether we should be allowing whales to be hunted. So because whales have been hunted, both for oil and for food, but then remember we also said that whales are one of those animals that have a slow reproduction rate. So they don't reproduce in large numbers. And because they've been hunted and because they have a slow reproduction rate, they are close to extinction, certainly endangered, and some types of whales are getting, they are extremely endangered and getting close to extinction. So the question becomes, how much do we allow whales to be continued to be hunted, even considering the fact that for some of the populations that hunt whales, it's partly a cultural or even religious thing. Other factors that figure into this are things like pollution. So because many fisheries are constructed along coasts, that affects things like estuaries. It affects beds of seagrass where often breeding and raising of the young occurs. And then those trawling nets that are used more along the coasts, they catch everything, not just the desired species, and often those other things are not returned to the ocean. So along these areas, in addition to those factors, then we get things like sewage and chemicals that also threaten these areas that are along the coast where many of these fisheries are located. So the questions that need to be addressed in terms of managing fisheries is, what is a suitable amount to harvest? How much is it okay to harvest? So some of the ways that we manage this is that one way that we manage it is that we say that it's legal to harvest only during certain times of the year. So in this country, we have times in the year when it is legal to harvest fish, and then there are other times when it is illegal to harvest them. And typically what is done is that we don't allow fishing during times of reproduction or during times of migration, because those factors are obviously very important in terms of the population of a fish. Another thing that can be done, and this is also done, is that we can regulate the size of fish that are allowed to be caught. So the reason that there are fishing regulations that indicate that fish can only be kept if they are a certain size is because you don't want the juveniles to be removed, because those juvenile fish can become adults, and so you want those juvenile fish to be able to become adults and to reproduce. We also can regulate the method of capture. So this varies depending on the species that is being caught, but we regulate how they can be caught so that too many are not removed. And then lastly, we can also certain areas are set aside where none can be captured. So that all of these management techniques are meant to maintain the population of fish so that there are adequate numbers to reproduce and sustain the population. Another way that populations are managed is by something called exclusive economic zones. So what this means is that any resources that are found up to about 230 miles from a country's borders belong to that country. So the country has complete control of the resources that are within about 230 miles. So other nations can fish there only if they have signed agreements with that country, and those signed agreements would state what can be caught and how much may be caught. So these exclusive economic zones keep just anybody from being able to come in and fish these areas that are they're on the right offshore of other countries. There are some areas that have typically been untapped. So around Antarctica, which is a pretty high productive area, but the problem with that is that we have to deal with the harsh climate in that area in order to be able to fish those areas. So another big thing that is being done is to try to promote other sources of protein. So fish are a major source of protein in the world, and in certain parts of the world they are the main source of protein. So countries are trying to do marketing campaigns that try to promote other sources of protein, or even promote other types of fish that maybe aren't considered as desirable as potential sources of protein, to keep one type of fish from being overfished. Okay, so let's talk about mariculture. So mariculture is, this really relates to farming and harvesting. About a third of all the fish that are eaten are farmed. So they don't come from the wild, they come from some type of farm. So there are two types of mariculture, and the first type of mariculture is an open mariculture. And an open mariculture is one where you close off an area of the coastline to sort of create a pond, and then you capture juveniles that are at sea and you put them into those ponds, and you control their feeding, and they may use things like cages or fences or rafts to protect them from predators, but the fish basically stay in their own environment. It's just that it is closed off. And then closed mariculture is where closed mariculture is completely controlled by the farmer. So in a closed mariculture system, salt water would be pumped into tanks, and then the water is monitored for salinity, it's monitored for temperature, and then that water is removed and you filter out the waste and other harmful organisms, and then it's returned. So the closed mariculture system is much more controlled by man. There are some problems with it. So when you have a large number of species that are held in one habitat, you can get disease or parasites. And also if you have too many of one organism held in an area where it is densely populated, they can actually start attacking each other and harming each other. So there are some disadvantages to a closed mariculture system. You probably have heard of something called stocking. So stocking just means that these fish are grown until they get to the juvenile stage, and then they are released. So then they're released back into the ocean so that they can be added to the natural population. So salmon, we do that with salmon. So we have hatchlings that are grown to young fish, and then they're released into the ocean. And then, interestingly enough, they will return to the mariculture facility that they were released from, and then some of those are harvested from the mariculture facility, but some are saved so that they can reproduce for the next generation. So there are some challenges to doing this type of thing because the equipment and the personnel to do it are expensive. And for some species, it's really difficult to reproduce the environment to completely reproduce the environment that they need for survival. Okay, let's talk a little bit more about, so we've been talking mainly about living resources, we've been talking about mainly using these ocean organisms as food, but there are other ways that we use them. So one way that ocean resources are used is in jewelry. So shells, pearls, coral, those are all used in jewelry. I already mentioned seaweed, which is used as a food additive. Some seaweed is also used in making plastics. And then, of course, skins have been used. Most commonly, seal skins or crocodile skins. We are also looking at ways There are a lot of studies being done now to determine whether there are potential medicines in the ocean. So we're looking for things like antibiotics, cancer drugs, painkillers. There are some ocean bacteria that it is thought they are anti-inflammatory and they could be used to treat skin disorders. So it's a big area of study right now is to determine what potential medicines might be available in the ocean. And then, of course, recreation is a big area as well. So there's deep sea fishing, there's diving, there are aquariums, and even saltwater aquariums that are in homes can, harvesting animals from the ocean for saltwater aquariums in the home can also impact the resources available in the ocean. Other factors related to the ocean, there are oil deposits and natural gas. So we find oil deposits and natural gas off of all of the continents except Antarctica. So there, let's see if I can find a figure. Maybe it's so here is an offshore oil rig that's in the Gulf of Mexico. So there are drill ships, there are platforms that are built and anchored to the bottom so that the oil or natural gas can be harvested in those areas. There are also minerals that are harvested from the ocean. So things like tin, iron, there's actually diamond that can be harvested from the ocean. Sand. So some of this is used in industry, and we're looking at there are scientists who are looking for things like gold, coal, manganese, nickel, copper, cobalt, and for some of those things, they're in the deep ocean, and it's too expensive right now to harvest those, but they are looking for ways to tap into it. Kind of related to this is the process of desalination. So desalination is removing salt from the water. So in areas where there is a scarcity of fresh water, there we are boiling it and trapping the water vapor in a desalination process. So here is a desalination plant where the salt water is, typically the water is boiled and you trap the water vapor. However, there are some other techniques that are being used. One is called reverse osmosis. And in reverse osmosis, what you do is you have the salt water is pushed through this membrane that is selectively permeable. The water goes through, but the salt and other dissolved substances cannot go through, so then you end up with the water that is desalinated, or that the salt has been removed. The last thing that I want to talk about in terms of how the ocean is being used is energy. So, and here we're dealing primarily with movement of tides. So when water moves in during high tide, that water gets trapped, and then it gets released at low tide, and that when it gets released, then that is used to turn turbines that generate electricity. It's not being done much today because generally the bays are too wide to construct barriers to trap the water. And there also, in order for this to happen, there needs to be pretty large fluctuations between low tide and high tide, and that mostly occurs at the poles because you get more of a pull of the moon. And the other problem with this is that it also changes the natural environment. So naturally occurring species can't live there if you start to mess around too much with this. But anyway, the energy of wave movement can be converted to electricity. It's not being done much today, but technology may advance in the future. Technology may advance to the point of making it a more useful energy source that can be used to generate electricity. Okay, so that finishes up the chapter on ocean resources, and the next chapter that we will cover will be